Hello friends, today we are going to start a new concept, capacitance. And to start anything newly, it requires more information. Therefore, it found very difficult to start. But once it starts, goes smoothly. Similarly, some electrical devices require a large amount of electric energy to start off the devices, like half HP, 1 HP, 2 HP motors, electrical fans, fridge, etc. Even a mobile flash requires a large amount of electrical energy. Therefore, a device used to start up to store electric energy and give it suddenly to start up is called a capacitor. And capacitance is denoted by C. It is the capacity or ability to store electric charges and give it suddenly is called capacitance, or capacitance of a capacitor or capacitance of a conductor is the ability or capacity to store large amount of electric energy and is denoted by C. And we start from a single conductor. A capacitor consists of two identical conductors separated by a certain distance, and the space between two conductors is filled with dielectric medium. Then now we start capacitance of a conductor, that is spherical conductor. Why spherical conductors are not suitable to store electric charges? Capacitance of spherical conductor. Spherical conductor. Consider a spherical conductor of radius r. Let r be the radius of the conductor. When a charge plus q is given to this conductor, it is uniformly distributed on the outer surface of conductor. You have studied in the first chapter. When charge is given to a spherical conductor, uniformly distributed on it. Let plus q be the charge given to the conductor. And as charge given to the conductor, its potential increases. And in case of spherical conductor, potential at any point on the surface of spherical conductor is equal to the potential at a point due to point charge. And if V is the potential on the surface of the conductor, then according to the definition, potential at any point on the surface is equal to K Q upon R, where R is radius of the spherical conductor and K is Coulomb's constant and its value is 1 upon 4 pi epsilon naught. Therefore, potential at any point phi equal to kq upon r or q upon 4 pi epsilon naught into r, because k equal to 1 upon 4 pi epsilon naught, where epsilon naught is absolute permittivity of free space or air medium, and its value is 8.854 into 10 to the power minus 2, and all these are constants. Therefore, k equal to 1 upon 4 pi epsilon naught equal to 9 into 10 raised to 9 Newton meter square per coulomb square. And potential at any point on the surface of the conductor is q upon 4 pi epsilon naught into r or kq upon r. And we know that when charge is given to a conductor, its potential increases. That means charge q is directly proportional to potential, or potential is directly proportional to the charge, or phi is equal to q upon c. Here 1 upon c is proportionality constant called capacitance of conductor. Thus, capacitance of conductor C equal to q upon p, and the SI unit of capacitance of conductor is, SI unit of charge is coulomb, SI unit is coulomb, C equal to q upon phi, coulomb upon volt, that is coulomb per volt, and is called farad. And is called farad. Farad is the larger unit of capacitance of a conductor, and smaller units like millifarad, microfarad, nanofarad, picofarads are used. And C equal to q upon phi, but phi equal to kq upon r or q upon 4 pi epsilon naught r. Substitute the value of phi in this equation, equation 1, that is C equal to, here we have taken take it as plus q with the charge given to the conductor, hence it becomes capital Q, capital Q, capital Q. And substitute the value of phi in equation 1, we get q upon kq upon r. Here q get cancelled, remaining 1 over k upon r. It can be written as C equal to r upon k, where k is Coulomb's constant and it is equal to 1 upon 4 pi epsilon naught. Therefore, capacitance C equal to 4 pi epsilon naught into R. It can be written as R upon 1 upon 4 pi epsilon naught. It is equal to 4 pi epsilon naught into R. Here, capacitance of spherical conductor is directly proportional to radius of the conductor. Directly proportional to radius of conductor. Then, to store a small charge of 1 microfarad, what should be the radius of spherical conductor? and it can be obtained as R equal to C upon 4 pi epsilon naught. And for C equal to 1 microfarad, and 1 micro equal to 1 into 10 raised to minus 6 farad. Substitute the value of C in above equation. R equal to 1 micro means 1 into 10 raised to minus 6 or 10 raised to minus 6 into 1 upon 4 pi epsilon naught is equal to 9 into 10 raised to 9. 9 into 10 to the power 9, that is equal to 9 into 10 to the power plus 9 minus 6, that is plus 3 meter. And 10 raised to 3 is equal to kilo. 1000, that is equal to 1 kilo, hence 9 kilometer. Therefore, even to store a small charge of 1 microfarad, a spherical conductor requires a radius of 9 km. That means the diameter of spherical conductor should be 18 kilometers. And it is unimaginable. It is impractical. Therefore, spherical conductors are not suitable to store electric charges. Hence, capacitors are built, and a capacitor consists of two identical conductors separated by a certain distance, and the space between two conductors filled with dielectric medium. Note down this. Now we shall discuss the principle of capacitor. Principle of capacitor. In one sentence, we can say the principle of capacitor is mutual induction. It is the principle of capacitor, and we discuss the principle of capacitor. What is the principle of capacitor? Mutual induction is the principle of capacitor. Consider a conductor M and let Q be the charge. Positive charge is given to the conductor. M be a conductor, charged conductor with positive charge. And now, if another conductor, identical conductor, is placed near another conductor, N is placed near M, what happens? Due to induction, negative charges are induced on the nearer or inner surface of N. These are the positive charges. It is positively charged. Therefore, negative charges are induced on N, inner surface, and an equal amount of positive charges are induced on the outer surface of conductor N. Here negative charges on N, it tries to decrease the potential of M, and positive charges on N tries to increase the potential of M. But the effect of negative charge is greater than the effect of positive charge because negative charges are nearer to plate M. Hence, it tries to decrease the potential of M and increases its capacitance. As potential decreases, capacitance increases. And now, if plate N is earthed, consider the same conductor, that is, it is positively charged, and on the inner surface of N, negative charges are induced and positive charges on the further end or further surface, outer surface. And if the conductor N is earth connected, if it is earthed, now what happens? The electrons from earth move to conductor N, and these electrons neutralize the positive charge. The positive charges are neutralized and electrons from earth move to the conductor, positive charges are neutralized. Therefore, now the plate N consists of only negatively charges, and it decreases potential of M further and increases its capacitance. This is the principle of capacitor. Then what is capacitance of a capacitor? We know that potential is directly proportional to charge given to the conductor. Let Q be the charge given to the conductors of a capacitor. Then the potential difference between the plates of a capacitor or conductors of a capacitor is phi. That means phi is the potential difference, and the potential difference between two plates is directly proportional to charge on the plates. And thus potential difference phi equal to 1 upon C into Q, or C equal to Q over phi, where Q is charge given to the conductors of a capacitor and phi is the potential difference between the plates. A capacitor is represented by identical conductors separated by a certain distance. This is fixed capacitor, and variable capacitors are denoted as, this is variable capacitor and it is fixed capacitor. The conductors may be rectangular, spherical or cylindrical, but the conductors are identical conductors. They can be rectangular, spherical or cylindrical conductors, and fixed capacitors are represented as shown. And Q is charge on the conductors of a capacitor, and phi is the potential difference between the conductors of a capacitor, then capacitance of a capacitor is defined as it is the ratio of charge given to the conductors of a capacitor to the potential difference between them. Potential difference between the plates of a capacitor. And the SI unit of capacitance of capacitor is coulomb per volt or farad, and denoted by F. And farad is the larger unit of capacitance. Therefore, smaller units like millifarad, microfarad, nanofarad, picofarad are used. And these are the smaller units of capacitance of capacitor. Clear? In next class, we shall derive an expression for capacitance of parallel plate capacitor. Parallel plate capacitor. And in this topic, what is capacitor? Capacitor is a device used to store electric energy and supplies it suddenly is called a capacitor. For example, electrical fans, they are provided with capacitor. We generally call it as condenser. Condenser and capacitor is the same. And electrical motors and fridge, they also provided with condensers or capacitors. They give a large amount of energy for their startup, and once they start moving and it is easy, it requires a low electrical energy. In houses, we get only a maximum of 30 ampere current, and out of 30 ampere current, a part of it is lost in the form of heat, and part of it is utilized to lit the bulbs and other appliances, and remaining part of the energy is insufficient to start up the fans, fridge, motors, etc. Therefore, they are provided with condensers or capacitors. They provide a large amount of energy at once to start. Hence, capacitors are most useful devices used in electrical devices. Thank you.